Hello everyone, I hope you're having a fantastic day today. Today we're going to be talking about vertical and horizontal shifts of trig functions. Now this is actually going to take us all the way back to the very first unit we did this year on functions, and we graphed them and we did transformations like moving them up, moving them down, left, right, making them fat, making them skinny, making them taller, making them short. This is actually going to take that same unit back from the very first unit we did, and it's going to apply it to trig functions. So let's get into it and kind of see what we're going to do here. First, you have general transformation form. That's just the general form that we put stuff in to make sure it's in transformation form. If it's not in this form, then we have to make it look like this as easily as possible. So a couple of things here. A and B are the same, so A is your amplitude, B is what goes underneath to find your period, right? And then you've got X plus or minus H plus or minus K. Now this H right here is going to be what moves it left or right. It's the phase shift or the horizontal shift. So what I'd like you to write is a plus sign. If it's X plus H, that moves it left. It's kind of counterintuitive because you're adding H and it's moving it left. But remember, this is the phase form, or this is transformation form. Alright, so I want you to remember, plus means you go left that number of units. Minus means you go right that number of units. So plus is left, minus is right. Now when you get on the outside of here, the plus or minus K, plus K moves it up, minus K moves it down. And we're talking about H over on the horizontal. So you've got H plus or minus moves it left and right. K plus or minus moves it up and down. It's the same on both of these forms. So if this was a plus H and a plus K, that would move it left and up. If this was the same thing here, plus H plus K would move it left and up. So minus H and minus K would move it right and down, that number of units. So it's a little backwards on the H. The K is pretty easy to remember because it's just straightforward. A little backwards on the H, but that's okay. Just remember that it's plus moves it left and minus moves it right. A is the amplitude. Remember, it's the distance from the axis of the wave. So here's what we're going to do. When we go to apply our shifts, first thing we're going to do is pick out some information from an equation. So amplitude is A. Look at the position of A real quick. We're dealing with sine. So A here is in front of sine. Well, what's the number in front of sine? Well, it's 3. So my amplitude is 3. My period here, remember that my period deals with B, and I've got to do 2 pi over B. Well, what's the value of B right here in between sine and the parentheses? Well, it's a 1. So it's kind of like saying 2 pi over 1, or just 2 pi. Okay, and then you've got a horizontal shift. Now remember, horizontal is H, so we're shifting, and since it's a X plus pi over 2, it's a plus sign, so I'm going to be moving left, so I'm going to put a left here, pi over 2. And a vertical shift, it's a minus 1, so minus K moves us down, so it's going to be down 1. Alright, so here's how we're going to do this. First, take care of your axes. The axes go through the middle of the graph vertically and the middle of the graph horizontally. Now if you think about your sine wave, it rotates pretty much along the x-axis. So let's think about this. Sine originally went through 0, 0. The sine of 0 was 0. So it originally went through this point. Now we're saying we're taking this point and we are moving it left by pi over 2, and we're moving it down 1. So here's what I want you to do. Go left pi over 2 units, and I'd like you to draw a dashed line on pi over 2. Now this is not an asymptote, okay? I want you to make sure you understand that. This is not an asymptote, this is an axis. So this is the middle of my sine function, if you would. Okay? And then down 1, So I'm going to go down here to down 1. This is now, this minus 1, let me turn this on its side so I can do this a little bit quicker. This minus 1 is now the middle of that sine wave. This is the middle. This is what our amplitude is going to be based on. Alright, here we go. So instead of going through 0, 0 and being wrapped around the x-axis, now it's going to go through this point and be wrapped around x is equal to, or excuse me, y is negative 1. So let's see what this is going to do here. First off, it says my amplitude was 3 and my period was 2 pi. Now since my period is 2 pi, that means that if it goes through this point, go 2 pi down the road, so here's 1 pi, here's 2 pi, that's where it's going to intersect my graph again. So somewhere in here I've got to have a full crest and a full trough, right? So let's see what happens. My period is 2 pi, that means halfway in between it, here at pi over 2. I'm going to hit my axes again. And my amplitude is 3. Go halfway here, go up 1, 2, 3. Go halfway here, go down 1, 2, 3. And what you've just created is the sine wave with a shift left pi over 2, down 1, an amplitude of 3, and a phase, a period rather, of 2 pi. And then of course you would fill in the rest. So you'd keep going here, go up 3, over to the middle where 2 pi is at, you'd have a maximum up here, you'd keep going, keep going, keep going. So your domain here makes pretty much sense. Your domain is all real numbers. And your range is negative 4 to 2. Okay? Negative 4 to 2. Alright? So when you're going through and doing these, I'm gonna give you a couple of little helpful hints along the way. This one was just pretty straightforward. The period is what makes these easier to do, because when I saw that that period was 2 pi, I know it's going to have the same shape as my other sine function. It's going to be the same shape going through the same spot. Now sine is easy to remember because it goes through the origin, so you just move the origin around and there you are. You flip to the next page, however, when you're dealing with cosine, it's a little bit of a different story. So let's get into this one here. First off, your amplitude. Now I'm going to have to rewrite this one because it is not in the form that I need it to be. I need this thing to be a cosine bx plus or minus h plus or minus k. Well, right now my k is in front. So I'm just going to rewrite this a little bit. Negative 2 cosine pi over 3 x plus 1. Since this is a positive 2, let's just move it to the back end here and put plus 2. It's not too much of a stretch. We're just moving things around, making them look like what we want to. Okay, so looking at a couple of things here. At the front part of this, my cosine is negative now. It's a negative 2. Ding. So what I would like to write here is because of this guy, we have an x-axis reflection. Okay. Now here's what that means. Originally, cosine when x was 0, originally cosine started up here at positive 1. Well, now, because it's a negative value in front of cosine, it's going to be down here. So it's going to take the cosine, it's going to flip it upside down. Okay? Let's go ahead and do some of this stuff real quick. My amplitude is the number in front of cosine, so that's a 2. Remember, it's always positive. Amplitude is always absolute value. Period, The number in between cosine and the parentheses is pi over 3. So that's kind of like saying 2 pi over 3. Simplify that down and you get 6. Right? Multiply by 3, divide your pi's out. Horizontal shift, again, this is left 1. Vertical shift is up 2. So again, it's easiest first to move the origin around. The origin is really easy to find. It's left 1 and up 2. So here's 0. Now notice your graph here. These are marked off in halves. So this is left 1 here and then up 2. So your graph has a little bit different, actually let me do this. Your graph has a little bit different of a setup. Now what I'm going to do here, let me switch to pen. I'm going to go ahead and label this axis. So this is the place around which my cosine function is now revolving. Okay, you see that a little bit better, I think, than pencil. This is the axis around which I'm revolving. See, remember, cosine was down here on the x-axis. Now it's going to be up here on this axis. Okay? So, if our original point was here, or excuse me, our original point was here, it was at 1, right? So we moved it up 2 and left 1. So our original point was here. Well, the first thing I'm going to do is my reflection. Reflect it across the axes. Watch what I'm doing here. Don't try and do this just yet. Just watch for a moment. I'm going to reflect it across the axes. I'm going to change my amplitude to 2. So instead of an amplitude of 1, now it's an amplitude of 2. Here's my first point. Again, watch what I do here. Start with the original point. Apply your transformations. Up 2 over 1. Do your reflection to get it down here. Change your amplitude to 2. Okay? Now from here, your period is 6. So here's negative 1, goes 6 units over. Your period is 6. That means the distance from this point to this point is 6. Here's my second point. Now this is going to look a little bit different because this is the middle of my graph. This line is the middle of my cosine. And since I'm going to 2, what I'm measuring here is trough to trough, minimum to minimum, or valley to valley. So go halfway between your distance, so go to a distance of 3, cut your thing in half. And from your line, apply a transformation, or excuse me, apply an amplitude of 2. So that's going to be up here. All right, so go halfway between these two, and halfway in between that is going to be a half right here, crossing over, halfway between these two here, 1.5 right here, crossing over. So your cosine function is going to look like this. All right. So again, what you're doing here is you are taking and applying a value for your amplitude, which is 2. So your amplitude everywhere should be a 2. The distance from the center of the trig function to the absolute maximum or absolute minimum, it should be a 2. And then all you're doing really from there is applying transformations. So it's up and left, up 2, left 1, and then just filling in the rest of the graph. All right, so then you can continue to fill it in from here. So your domain is, again, all real numbers. Range here, 0 to 4. All right, let's go to number 3. I'm gonna start cooking through these at a pretty good clip here. So your amplitude on this one is the number in front of cosine, that's 1. Your period is 2 pi over 4. Or you can simplify that down to pi over 2. Notice the x-axis is broken up into pi over 2's now.